Hi everyone, I am Dr. Subbarao from RVIT of Technology. In this video, I am going to explain glucose biosensors and amperometric sensors. The first one is the glucose biosensor. The potentiometric sensors are used in analysis of glucose in blood. So blood having the glucose content, how much glucose present in blood. This can be detected by using glucose biosensors. I'm showing here the diagram. This one is used for the detection of glucose in blood. So this glucose biosensor having the glucose dioxide is coated on the electrode, which is acting as the detector. And glucose is converted into ions, which is detected by ion selective electrode. And glucose is oxidized into gluconic acid, which is further undergoes decomposition and gave hydrogen ions, which are detected by the pH electrode. If you see, this is the electrode and the electrode is coated with glucose oxidase. This one is the glucose oxidase acting as the catalyst. This glucose oxidase converted glucose into gluconic acid and hydrogen peroxide. So here the hydrogen peroxide further undergo reduction. That means this hydrogen peroxide reduced to form the hydrogen ions and it liberates the oxygen gas also. And the liberated hydrogen ions are detected by the electrode. So this is the typical mechanism involved in acting of glucose biosensors. And these are the chemical reactions involved during the detection of ions. So initially this glucose is mixed with the atmospheric oxygen in the presence of the glucose oxidase. The process is called the oxidation process. So the glucose undergo oxidation in the presence of glucose oxidase and forms the gluconic acid and hydrogen peroxide. This hydrogen peroxide further undergo reduction and it gives the hydrogen ions and oxygen gas, and also it liberates two electrons. Here the two hydrogens were detected by the electrode. The hydrogen ions measured by the pH meter, the potential difference is set up between the glass electrode and the reference electrode, which is sensed by potentiometric sensor, which analyze the glucose level in the blood. This is the working of glucose biosensors. Now coming to the amperometric sensors. These amperometric sensors detect the harmful gases in the atmosphere or surroundings. And also these are helpful to detect the harmful chemicals present in liquids or water. These amperometric sensors are analytical devices that measure current change at a constant potential to determine the concentration of an electroactive substance. So this one is very helpful to detect the current change at constant potential. So whenever the mixer having the different compositions, that means different kinds of gases. For suppose if atmosphere contains a mixture of gases, we can detect the single gases. That means single molecules of gases we can detect. By using that, we can also detect the concentrations, how much concentration of that gas will be exist in that atmosphere. So for example, if you want to know the oxygen content present in a particular room, so at that room, the sensor will detect the concentration of the oxygen. And they are widely used in biosensors and other applications for detecting the various substances in liquid or gaseous phase. So in gaseous phase also we can detect, and liquid phase also we can detect. Now coming to the working of amperometric sensors. So these are the original amperometric sensor. This amperometric sensor having the two electrodes. One is working electrode and another one is the reference electrode. So the amperometric sensors utilize an electrochemical cell with at least two electrodes. One is a working electrode. At working electrode, the redox reactions will take place. And next another electrode is the reference electrode. This reference electrode maintains the stable electrode potential and the current generated at the working electrode, which is directly proportional to the rate of the electrochemical reaction. This reaction is typically diffusion controlled, meaning the rate is limited by how quickly the analyte can reach the electrode surface. So this will be working of the amperometric sensors. So diagrammatically I can explain simply. So here if you see, this is the oxygen permeable membrane. That means it will filter the gases and it allow only oxygen content into the chamber. And this is a glass electrode. This glass electrode consists of two electrodes. One is a working electrode, which is called as a cathode. And the second one is the reference electrode, which is a anode. And this one is the electrolytic solution. And this total glass is filled with an electrolytic solution. By depending upon the working electrode, the nature of the material will be made with. So that is the reason. If the electrode is a zinc electrode, then we will be using the zinc sulfate as an electrolyte solution. If you use the graphite electrode, then we use the KCl solution or some acids like hydrochloric acid. So these are the electrolyte solutions used in this amperometric sensors. These are also depending upon the nature of gas and the contents which are used in this manufacturing of the electrode. So here this oxygen permeable membrane allows only oxygen. They will restrict the other gases like nitrogen oxide, carbon dioxide. And this one is the cathode here. Here the cathode, the oxygen is absorbed by the cathode and here the reactions will take place. And the liberated electrons will be detected by the cathode and which will be converted into signal form and give the concentration value. So this is the working of amperometric sensors. Now coming to the key features and applications of amperometric sensors. The first one is the sensitivity and selectivity. Amperometric sensors can be designed with high sensitivity and selectivity, allowing for the detection of specific analytes even in complex mixers. And the second one, wide linear range. They often exhibit a wide linear range of detection, meaning the measured current is proportional to the analyte concentration over a broad range. And the next one, portability and low cost. Amperometric sensors can be made small, portable, and relatively inexpensive, which making them suitable for various applications. Next one, applications of amperometric sensors. So applications in biosensors for detecting glucose, lactate, urea, and other biological molecules. Applications in environmental and monitoring for detecting the pollutants in air and water. So we can detect the pollutants in water and also air. Next one, industrial applications. So industrial safety and process control by monitoring the gas concentrations and other parameters. Next one, applications in homeland security for detecting the explosives or other threats in the land. Medical applications assisting in diagnosis and treatment process. Thanks for watching. If you like this video, Please like, share and subscribe. Please click the bell icon symbol for more informative videos. Thank you.